Hello everyone, I welcome you back to my YouTube channel. So in the subsequent videos I'm about to post, or I will be posting, it will be on partial fractions. Okay, so we are going to tackle partial fractions. Now, partial fractions comes in different forms. Okay, so we have questions on partial fractions which has linear factors. We have the ones which have quadratic factors. We have ones with repeated factors. The repeated factors could be either a linear factor, a quadratic factor, or could be both of them. Then we have one which comprise of the first three. So you can have a question on partial fractions which has both linear factors and quadratic factors. You can have both quadratic and repeated factors in them. Yeah, it could be a mix of all the three or just two of them. Okay, so we are going to tackle them one by one. So in this video, we are going to start with the first one. Okay, so partial fractions with linear factors. So a fraction of this form, let's say a on ax plus b. If you have a fraction like this, if you take the denominator is the ax plus b. Now this denominator over here is a linear factor. What makes it a linear factor? What makes it a linear factor is the presence of this x. Okay, in other words, you can say that the highest power of x at the denominator part is 1. Okay, and any expression with the highest power of x being 1 is a linear factor. Okay, so partial fractions containing linear factors can come in a form like this. So it can come in a form like, let's say, a x plus b. Let me use a different one. Let's say ax plus b all over ax plus b in small letters cx plus d. So you can have a fraction like this. If you check the denominator, we have factors which are linear factors. So if you are given a partial fraction like this and you want to resolve or break them down into a partial fraction, if you are given a question like this or a fraction like this and you want to break them down into partial fractions, you can follow how we do it for linear factors because the denominator is having linear factors. So you can follow that approach and then resolve it into partial fractions. Okay, now it is not all the time that the denominator will be resolved or will be factored out for you like this. Okay, sometimes it will be given in a quadratic form, sometimes it will be given in a cubic or a quartic form. It depends on the question, right? As long as you can factor out the denominator, or you can factor the denominator to get a linear factor, you can follow the process and the procedures to resolve a fraction into partial fractions which contains the linear factors. Okay, so in this video, you are going to start with linear factors. Okay, so let's start with the general form. Okay, so let me maintain this one. So let's start with the general form. So if you have any fraction in this form, now the linear factors I'm talking about is always at the denominator part. The numerator has nothing to do with it. Okay, it's always at the denominator part. Okay, so now if you have a fraction like this and you want to resolve it into partial fractions, it is always of the form. It's rather unfortunate I've already used a and b. Let me use different letters over here. So let's say this. Yep, so it's always of the form a over the first factor, which is ax plus plus b plus b over the next factor, which is cx plus d. Now mind you, x is the only variable in this case. All right, all the other variables being used are numbers, so they are representing specific numbers. Okay, so if you have any fraction of this form and the denominator is having linear factors, you can write it in partial fractions of this form. Okay, so let's solve some examples. Okay, so let's take our first example, change it to that. All right, so let's take our first example. Oh, didn't change. All right, let's maintain it. So example 1, let's say we have, all right, now before we begin our examples, let me add this. Whenever you want to resolve any fraction into partial fractions, first thing you're supposed to check is to see that the fraction you are being given is a proper fraction. Now, how do you check whether the fraction is a proper fraction or an improper fraction? Now, if the expression at the denominator side, because it's a fraction, you'll be given an expression at the numerator side and then another expression at the denominator side. Okay, so let's say we have ax plus b all on cx plus d. Now, for a fraction in terms of expressions to be a proper fraction, the highest power of the denominator should be bigger than the highest power of the numerator. Okay, so if you have x plus 1 over x plus 2, the highest power of the numerator here is 1, the highest power here is also 1. Because the highest power of the denominator is not greater than the highest power of the numerator, this becomes an improper fraction. Okay, if you have a fraction like, let's say 2 on x plus 1, the highest power of x at the denominator part is 1, the highest power of x over here is 0. Okay, you can attach an x power 0 over here, doesn't change it, so this becomes an improper fraction, a proper fraction. So this becomes a proper fraction. Okay, in the same way, if you have, let's say, x plus 1 on x squared plus 2, this is also a proper fraction. Right, so you can only proceed to resolve it if the fraction given is a proper fraction. If it's not a proper fraction, you first have to use the long division method to break down the fraction into two parts. Right, we solve examples like that so you get to know how we go about it. All right, so let's begin with our first example. So in our first example, we have this problem: x plus 1 all over x plus 2, then x plus 3. Now we have to resolve this into partial fractions. Okay, so the first thing you are going to do is to write the form. Okay, so because this is having the linear factors, we can write this expression or this fraction as a on the first factor, which is x plus 2, plus b on the second factor, which is x plus 3. Now what we are going to do at this stage is to combine the expression at the right side. Okay, so I'm talking about this whole expression. We are going to combine them to get a denominator like this. So let's say we are maintaining the same, then x plus 1 on x plus 2 multiplying x plus 3. So this, you can use equal sign, right? This sign is just representing an identity. Okay, so this will be equal to, we're just combining this fraction. Okay, so let me write it well. So we are going to have a multiplying x plus 3 plus b multiplying x plus 2, and this whole thing divided by x plus 2 x plus 3. Now since we have the same denominators over here, we can equally say that for these two expressions, that's the expression at the left hand side and the one at the right hand side, for them to be equal, that means their numerators too must be the same. Okay, so at this point we can just proceed and ignore the denominators and just compare the numerators. Okay, so we now have this. Now at this point, there are two ways you can go about getting your values of a and b. Right, now we just want to get the values of a and b over here. Right, we're interested in finding those values. Okay, so to get your values of a and b at this point, you can use two different ways. The first method is the cover up rule, and then the other one is the expanding and then comparing of coefficients method. So the cover up rule works in this way. You just substitute any value of x at all to get rid of one variable so that you'll be able to find the value of the other variable. So for instance, I can say that when x is equal to -2, that is when we replace x with -2 into this equation over here, we are going to get this side as 0, right? So in that case, by making a direct substitution of -2, we get rid of the variable b so that we can find the value of the variable a. Okay, so that's how the cover up rule works. Now for the substitution, for the expanding and comparing of coefficients method, I personally like that method because sometimes the cover up rule doesn't work for all of them, right? Okay, now the cover up rule doesn't necessarily mean you should try and then eliminate one variable. Okay, sometimes you can just substitute any value of x at all into the equation to get simultaneous equations so that you solve them simultaneously. Yeah, but in the same way, if you use the expanding method too, we are going to get simultaneous equations and then proceed and then solve them. Okay, so we are going to use the expansion method. So we are maintaining the x plus 1 over here. Now we expand the expression at the left hand side or the right hand side. So we are going to get this plus bx plus 2b. Okay, now at this point, what we are going to do is to group like terms. So we are combining all the x's and then all the constants. So we can combine the x and write it as a plus b or multiplying x. Okay, there's an a here, there's a b here, they all having x attached to them, so we can combine them by factorizing out the x. Okay, then plus the rest are just constants because there's no variable attached to them. Now at this point, what we are going to do is to compare the coefficients on both sides. So if you take the left hand side, the coefficient of x here is just 1. Okay, there's a 1 here, but we don't normally write it. Okay, so you can just write that by comparing coefficients, you can see that a plus b, that is the coefficient of x over here, is equal to the coefficient of x over here, which is 1. Okay, so because they are the same, that means the coefficient over here should also be the same as the coefficient of x at the other side. So let's call this as equation 1, and then we compare the constants as well. The constants at the right hand side is 3a plus 2b should be equal to the constants at the left hand side, which is also 1 in this instance. So this is an equation 2. Right, so at this point, what we have to do, we have to solve these two equations simultaneously for the values of a and b. Okay, so you can use either the substitution method or the elimination method. There are other methods too, but those are the only two mostly used. So I'm going to go with the elimination method. You can use any method you want. We're still going to get our final answers. So you can multiply equation 1. So equation 1 can multiply equation 1 by 2. In that instance, we are going to get this equals that. You can proceed and then write them as this equals to, let's call this equation 3. Okay, so now we compare the 3 and then the 2. We want to solve it by elimination method. There is a 2b here, there's another 2b right here, so we want to eliminate the 2b. They are all positive, so we can do that by subtraction. Okay, so let's subtract equation 3 from equation 2. So equation 2 minus equation 3, so that is 3a minus 2a, then 2b minus another 2b, that cancels out to give us 0, right? So we can move on to the other side. Equals, there's a 1 here and there is a 2 here, so that gives us 1 minus 2. So just do your subtraction. You're going to get a equals 1 minus 2, which is negative 1. Okay, so we've gotten our value of a to be negative 1. Then we can, by direct substitution, so we can put a equals negative 1 into any of the three equations, right? Any of the three equations, you can put the values of a into it. So let's use equation 1. So what is equation 1? Equation 1 is over here, right? So by doing that, we are going to get negative 1 sorry guys. Alright, negative 1 plus b equals 1, right? So we just replace a with negative 1. Right, so we are going to get b equals 1. Move this to the other side. 1 plus 1. B is going to give us 2. So we have values of a and then b. So at this point, what we are going to do is to just make our substitutions back into our expression. So we are now back to this side. Okay, this was our expression for the partial fraction of this fraction. Okay, so we've now gotten values of a and b. You can now write that x, so therefore x plus 1 all on x plus 2 multiplying x plus 3 equals negative 1 over x plus 2 then plus 2 on x plus 3. So this is going to be your final answer. Okay, so if you resolve this fraction into partial fractions, this is what you're going to get. You can verify your answer to see whether it's correct or wrong in so many ways, right? But the one I prefer is to substitute a value of x into the left hand side. Okay, and then use the same value of x and substitute it into the right hand side. If you get both values to be equal, that means your answer is correct. Okay, so that is one way you can use to verify your answer, see whether it's correct or not. So that was for the first question. Okay, now for the second question, let's try this. So number 2, I'm just making questions up. So let's say x plus 2 on, let's use x squared plus, okay, let's use x squared minus 3x plus 2. Okay, now if you check the denominator, it's been given that the denominator has been given in a quadratic form, right? But that doesn't necessarily mean it falls under quadratic factors, right? You have to check to see whether you can actually factorize the denominator. Okay, so yes, we can factorize the denominator in this instance. So we are going to get x plus 2. If you factorize the denominator, you are going to get x minus 1 in one bracket, then x plus 2 in another bracket. Sorry, minus is over here, besides minus. Alright, so this is what you're going to get. So by factorizing the denominator, we've gotten the denominator as linear factor. So you just have to follow the same procedures we followed to deal with the first question. Okay, so let's write an expression for the fraction x minus 1, x minus 2. So it's in the form a on x minus 1 plus b on x minus 2. Okay, so I'm going to get x plus 2, x minus 1, x minus 2. So a x minus 2 b x minus 1, x minus 1, x minus 2. Okay, can ignore the denominators to get this. Let's expand it. I'm going to get ax minus 2a plus bx minus b. Okay, so grouping like terms, a plus b all in one bracket, x plus minus 2a minus b in another bracket. By comparing coefficients, we are going to have a plus b equals 1, because this is the coefficient of x, the coefficient of x. Then minus 2a minus b equals 2. Okay, so this is our first equation, second equation. Okay, so just solve them simultaneously. Let's do this by elimination method. You can add 1 and then 2 to get rid of b. Okay, so that gives us a plus minus 2a equals b plus minus b gives us 0. So equals 1 plus 2. This gives us minus a equals 3. Then a gives us minus 3. So this is our value of a. Okay, so we can make direct substitution by putting a equals negative 3 into any of the equations. Let's say equation 1. So what is equation 1? A plus b equals 1, right? So by substituting negative 3 into the position of a, we're going to get negative 3 plus b equals 1. So b is going to give us 1 plus 3, b is going to give us 4. So we've gotten our values of a and b. So that means our fraction in terms of partial fractions is going to be, so we have x plus 2. We always use the original question. Okay, b equal to was a, so it's equal to negative 3 on x minus 1 plus 4 on x minus 2, and this is going to be our final answers. All right, so yeah, that's how we go about with the linear factors. Okay, yep, that's how we go about with the linear factors. So you just have to, if it's given in a quadratic form, check to see whether you can factorize it, yep, before you come to a conclusion that it's a quadratic factor or not. Okay, so let's solve one more example. It's the one with long division method. So that is example 3. Okay, so let's use let's see, x squared plus x plus 1 all over, let's use the same factor as one in the previous example. Okay, so now this is an improper fraction. You can't just factorize this one out and then proceed and then simplify or get your answers for a and b. What you have to do first is to use the long division method to divide this fraction. Okay, so to reduce this fraction to a proper fraction. Okay, so if you don't really know how to use the long division method in this case, let me know in the comment section so that I'll make a video about that one. Okay, but at this point I'll just proceed and then go through the long division method. So x squared minus 3x plus 2 outside, then x squared plus x plus 1 inside. So we just consider this first one over here, x squared, then consider the first term over here as well. So the one here is dividing the one over here. Okay, so what I mean is that this x squared is being divided by this x squared. Okay, so this is the first one and this is the second one. So it is 1 divided by 2. So if x squared is being divided by this x squared, what are we going to get? We are going to get 1, right? We're going to get 1. Then we multiply this 1 with the whole of the expression over here. Okay, So what are we going to get? 1 times x squared is going to give us x squared. 1 times minus 3x is going to give us minus 3x. 1 times 2 is going to give us plus 2. So do a subtraction. Okay. So by doing subtraction, we are going to get, so 1 minus 2 is going to give us minus 1. X minus negative 3x is going to give us 4x. X squared minus x squared is going to give us 0. Okay. So after dividing, we got x squared plus x plus 1. X squared minus 3x plus 2. We got it to be, now whenever you divide an expression, it's always in the form quotient plus remainder over divisor. Okay, so the quotient is the answer you had over here, the remainder is the expression you have here, and then your divisor is your denominator. Okay, so we have now in this. Now after getting it in this form, you can see that this is now a fraction which is also a proper fraction. So you can proceed and then resolve only this side by following the linear factor approach. Okay, so you first divide it using long division to reduce it to a proper fraction, then you proceed and then you solve it. Okay, so let's quickly go through that process too. So we're going to get 4x minus 1. This is x minus 1, x minus 2 in the form, say, a on x minus 1 plus b on x minus 2. Okay, so you are simply going to get this equals a x minus 2 x minus 1. Okay, so 4x minus 1, we are going to get a plus b. I'm just skipping some of the procedures since we are already familiar with the procedures. So minus, then you're going to get minus, sorry, here's plus. So plus, you're going to get minus 2a minus b. Alright, so by comparing, you're going to get a plus b equals 4, first equation, minus 2a minus b equals minus 1, second equation. You can just add 1 and then 2. This gives us a plus minus 2a, then equals 4 plus minus 1. So this gives us minus a equals 3, a equals minus 3. So at this point we put a equals minus 3 into, let's use equation 1. So a plus b equals 4. So that means we are going to get minus 3 plus b equals 4, b equals 4 plus 3, b equals 7. Okay, so now what will be our final answer? Just write the original equation, the original fraction given. That was x squared plus x plus 1 all on x squared minus 3x plus 2 equals 1 plus, then the fraction you resolved. What was your final answers? A was negative 3, so that means the sign should change. So 1 minus 3 on x minus 1, then plus next one is 7 on x minus 2. So this will be your final answer as well. So basically this is how you go about when dealing with the ones with linear factors. Okay, let me quickly go over the procedures again. You first check to see whether the fraction is a proper or an improper fraction. Okay, if it's an improper fraction, that is if the denominator has a highest power less than or equal to the highest power of the numerator, that is an improper fraction. So you have to use the long division method. In other words, if the highest power of the denominator is not greater than the highest power of the numerator, it's an improper fraction. So use the long division method to break it down into proper fraction, then you resolve it. If it's a proper fraction as well, just follow the same procedures. Okay, so I'll see you in my next video with the next method. Goodbye.